So in dealing with exponents, whenever we have something that's being multiplied by itself multiple times, um, for example, if we have, 3 being multiplied by itself, um, it's being multiplied by itself 3 times. So what we have here is the number that's being multiplied by itself is called your base. So the number that is being multiplied by itself is called the base. And then the amount of times that is being multiplied by itself is the exponent. So we can write this as 3 as our base, and then our exponent is going to be what? Right, 3 to the 4th power. So again, here, the 3 is your base, and the 4 is your exponent or power. And this is considered to be exponential form. So we can exponential form, whereas when we multiply it the way that we see up here, that is called your long form. One thing to be careful about is if you have negatives in a problem. And that's always, anytime you see a negative, just like in real life, you have to be careful because there's something about the negative that's going to be different than how you complete the problems. So, when So if we have to write this in exponential form, what we have to be careful of when we see a negative is that if all of them have a negative. If all of them have a negative, then that's your base. So if all of the numbers have a negative sign, then the negative number is the base. And what's important is that you have to write it inside of parentheses when you do the long form, exponential form rather.
So with exponential forms, the rules of the signs don't apply.
Yes. Yes.
Mm-hmm.
Yes. So this one, when we write it in long form, or in exponential form rather, we would take that -8, put it inside of parentheses, and then our exponent is going to go on the outside of the parentheses, which is what? All right, 5. So -8 inside the parentheses to the 5th power. It's very important that you follow this rule because when it depends on whatever our exponent is. If we have an even exponent, and actually I should put negative base inside of parentheses because it's going to make a difference. Then your result will be positive. An even exponent with a negative base inside of parentheses, you're going to get a positive result. So for example, if we have -4 and that's being raised to the 2nd power, it's an even power. So since it's an even power and we have negative base inside of parentheses, the result is going to be positive. So positive 16. Yeah, yeah. And any even. hmm hmm So you and you should learn how to use your calculator um, for problems that involve exponents, because if you get a problem like this, for example, it's going to give you a large number, very large number. So if you're multiplying it out by hand, then you will have to do -8 times -8 times -8, and it's going to give you a large number. So, and if this power was even bigger, that number is going to be even larger. So that's what exponentials or exponent does. It makes things move exponentially. So, and if we were talking about linear, linear moves like this in a straight line. But exponential, it goes up fast in a like in a curve like that. So it would be important to know how to use a calculator for something like this. And let's just look at what a typical calculator would do. If we wanted to do this, you will have a button on your calculator. It may look something like this: x to the y, something like that, or it might say y to the x. So what you have to do is you put in your -2. You should have a negative button, not the minus button, but you should have a negative button somewhere on your calculator. And if you have parentheses, I will put that in parentheses like that. Put it in parentheses and then your -2. Then you hit that button, x to the y, and then your equal button. And then that should show you, that the result is going to be 16. So whatever type of calculator that you have, do a search on it in Google or somewhere and see how to properly calculate powers with that particular calculator.
Should we have a calculator for this class?
Well, yeah, you should get one. You should get one because you're going to need it as you move on. Hmm? Yeah, as we move on, the problem, especially with problems involving power, you don't want to, if you're taking a test, you don't want to use a lot of time multiplying it out, especially if you have a time limit. And now what you can do, in our case, you can show me, that if you were going to multiply this out, it would look like this. But when you have very large powers, you're going to want a calculator. Yeah, I would say the one that I like to use the most is a Casio calculator, a Casio FX calculator. It's a Casio. And it's a FX. I don't remember the actual number, but FX something. And they cost, no more than, $16 or something.
Does the store have them?
Yeah, Walmart usually does.
The school store?
Uh,
Yeah, they do.
they have Casio? Okay, good, good.
They're really expensive, but they have them here. Amazon has it.
Well, you don't need the most expensive one because there's all different types of Casio calculators. But the one that I'm talking about, it's about, $15, $16 at Walmart. And it has a big screen on there. So the buttons that you actually use, let's say, for example, this button right here. What it does, it gives you the prompt to put in, it will tell you put in what your power is, and then you put negative 16 negative 2 rather, but I would tell you to put it inside of parentheses and then your power. So you will put in the whatever your power is. Let's say if it was 7, you put it in. So that's what the Casio calculators are much easier to use than the Texas Instrument calculators. Um, but and whatever the case is, if you have this power, I know I wouldn't want to be writing it out, multiplying it, because it's going to give you a big number. So if you have this here, you can show me on your test paper, this is how I would do it, if I was going to multiply it out in long form rather. But but otherwise, especially with power problems like this, you're going to need a calculator. Let me get you to sign in first. Now the other thing that we want to take a look at is when you have an odd power. So this one involved an even exponent. When we have an odd exponent with the negative base inside of parentheses, then you're going to have a negative result. So if you have an odd exponent with the negative base inside of parentheses, you're going to get a negative exponent. So the odd numbers again, 3, 5, 7, and so on. So that something like this is going to give you a negative result. So if you know that rule, and you have to calculate 3 to the 5th power using your calculator, you know, you can just use the 3 to the 5th power and then, you know, put your negative in your answer. So 3 to the 5th power, what do we get? Who has a calculator?
It came up as 243.
243. So it would be a negative 243. So that's one way you know, you can do it. You know, if you don't have a calculator that shows you your parentheses. The
So is this finding possibilities?
hmm?
Is this finding the maximum possibilities?
No, this is making a calculation. So in other words, negative 3 times negative 3 times negative 3 5 times, or in your calculator.
5 times, let's say you have 5 placings and you do 5 times 4, 5 times. Then you take that number, then times 3.
No.
Totally left field, aren't I?
Well, and this one, if we were looking at it in long form, you know, this is how it would look. So 5 times, three times, negative 3 times itself 5 times. But if you have a calculator, you can look at it from here. Negative times a negative gives you a positive. Then this positive times this negative gives you a negative. So now we have a negative times a negative again, which gives you a positive, times a negative, which gives us back a negative. But, you know, you don't want to waste a lot of time making the manual calculation with powers like that. You should have a calculator where you can punch it in that form and come out with the result. And you're going to need it for the next class anyway. So if you have it now and start learning how to use it, that would be the best thing. Did you have any other questions on that one?
I do, but
Yeah, ask maybe.
no, because I think that's, formula. So
Okay.
I don't want to waste the class time.
Okay. Okay.
Okay.
Yeah.
My brain is so complicated and I can't make sense of it myself, so.
Now, if you have no parentheses, if you have no parentheses for a negative number with a power, the result will always be negative. And it doesn't matter whether you have an even or an odd exponent or what have you. So no parentheses there. The way that this would look in long form, you know, if we were to to, actually let me put a 4 here. The way that this will look in long form, if we were to write it out, the base will actually be positive. So this negative is on the outside there where we have the base as positive 5. So that's why you're going to always have a negative result when this happens. No parentheses. So what do we get? Punch that in the calculator. 5. Well, since we know what the result is going to be negative, just put 5 to the 4th power. 625. And if so unlike this here where we have the negative inside of the parentheses, when it's not in parentheses, we're going to always have a negative result. And it doesn't matter, if you have even or odd exponent. Even or odd exponent, it doesn't matter. So that's why you have to be careful when you're working with negatives, because we have these different rules involving whether it's inside of parentheses or not. And you could have a problem, something similar to this, and it'll ask you show how this will look in long form. This is your long form. Working with variables, the idea is the same. We have w times itself. So our base in this case is what? Is the w. And then the exponent? 4. Right. Okay, great. W to the 4th power. So the same rules apply if we have exponents or not. whenever we come out with the actual answer for a problem that's written in exponential form, we're actually evaluating it. So if you get a problem that says evaluate 3 to the 4th power, that just means that they want the actual result, what the result of it is. So what would that become? And, and um, yeah, right. Because the long form, if we were looking at it in long form, you know, it would look like that. And that would be 9 times 9. You know, if we were looking at it that way. Oh, okay. Okay. We are evaluating negative 4 squared. Positive or negative? Negative. Yeah, negative. No parentheses. So whenever we have no parentheses, we're going to always have a negative result.
How do you do that in a calculator?
You will have to use the negative button.
See, that's what
So
I did negative.
yeah, see those calculators may not be able to follow order of operations in that way. So like the Casio one that I was telling you about, you can put it in and you can see it on the screen just like that, and it'll make the calculation there. Oh, okay, yeah. Yeah, yeah, you have to be careful also not to use the minus sign. Even though minus and negative is the same thing, you can't use the actual minus sign when you have it there. So here we have negative 4 inside of parentheses to the 2nd power. What is our result? Positive, right. Negative 1 to the 20th power. Positive 1. We have a positive, a even exponent there. So, so here we want to evaluate 2 squared plus 7 squared. So with these, we're just taking the actual results. So 2 squared is what? And then 7 squared.
7 times 7.
49, right? Okay. And then we just add them together. And that's our result for it there. So when we have to evaluate, we have to come out with the actual result. So we have a fraction that's being raised to a power. The way that we work with this type of problem here, whenever we have a power that's a fraction that's being raised to the power, that a power will apply to both the numerator and as a power to the denominator. So whatever power it is, we apply it to both the numerator and the denominator.
I have 81 for the top.
Okay, 81. And 256, and then we have to see if we can reduce it. So if you don't recognize what can go into both the numerator and denominator, what can you try? Oh, okay.
I was gonna say,
So
that he's a decimal, I would have had 3. I would have done 3.
well, because when we look at 81, we can it's possible that it won't reduce, but you can, when we look at 81, we can either look at 9 times 9, then we can see if 9 divides evenly into 256. It doesn't. So then we can look at maybe 3 and see if 3 divides in.
But not into 56.
Okay. If not 3, then we can try, like here we will get 9 times 3 times 3. So if we look at 9 times 3, that gives us what? So we could try 27, see if that divides evenly. And that's all of the possibilities that we have. Oh, oh, okay. I started with 9 times 9, so 9 didn't go into it. So I broke 9 times 9, to 3 times 3 and 3 times 3. Same thing as 9 times 9. Right here, 9 and 9. Well, 3 times 3 is 9, right? times 9. So I broke that up.
So you just kind of simplified it.
Well, factored it out to 3, right?
Okay.
Mm-hmm. So we looked at 3 and 3 didn't do it. So now I said, okay, since this gives us 9, let's try 9 times 3, which is 27. 27 doesn't go into it. So now we have no other options to factor it into. Or we could see, of course you would have tried 81 first
I
to
did
see if
that with
81.
3, and then I couldn't, it wasn't going through, it gave me a decimal.
Yeah,
So
yeah.
like, that's not gonna work.
So, we can't reduce it any further. And our final answer would be the 81 over. Okay. So the last problem for today. So this one is reading 5 squared, or 5 to the second power, times 2 to the third power. Now you would evaluate them individually at first, and then take the product. 25, right? And then 8. And that's going to give us. All right. Okay. Get everybody to sign in.